All right, let's take a look at number 3. So here we have cosine is 1/4. We're in the fourth quadrant, so quadrant 4 here, right? And so in quadrant 4, cosine is positive, as we can see, right? But sine is going to be negative, all right? So we make our triangle, and you can make your triangle in the fourth quadrant if you want. You don't have to. You can just kind of make it anywhere, and then just make sure that sine ends up being negative. But if we have our triangle here, this is theta, right? Always between the x-axis and the terminal side. And so since cosine is adjacent over hypotenuse, or x over r, this would be 1 and this would be 4, right? And this is not a triple, so we're going to have to do Pythagorean theorem. So to find y, or this other side over here, we're going to do x squared plus y squared equals r squared, or a squared plus b squared equals c squared. And so we'll get, we'll square the numbers, take away 1 from both sides. So end up with y squared equals 15. Take the square root of both sides, so we get y equals root 15. That can't be simplified, right? So root 15 is what we put right here. And so sine is root 15 opposite over hypotenuse is 4, okay? All right. And so we have everything we need to find what they're asking for, right? So now we'll just start to plug all this stuff in. So let's start with sine of 2 theta. So sine of 2 theta, right? We're gonna put root 15 over 4 here for sine, and 1/4 for cosine, right? So it'll be root 15 over 4. Oops, I forgot the 2. Put that in there. So 2 root 15 over 4 times 1 over 4. And so I'll multiply 2 on top. So it'll be 2 root 15 on top. 2 times root 15 times 1. And the bottom 4 times 4 is 16. 2 over 16 reduces. I could have actually reduced here, right? Or maybe it would have been a little easier. But I'll reduce here instead. And so we'll end up with root 15 over 8. Okay, so that's what sine of 2 theta is in this situation. So let's look at cosine of 2 theta. Now we can use any one of these formulas that we want. I'll just use this one since it won't have to deal with the radical, and that's one we could have done without finding this, right? So that would be 2, and I'm going to put, instead of cosine squared, I'm going to put 1/4 squared, right? So it'll be 2 times 1/4 squared minus 1. And 1/4 squared, we'll do that first. So 1 times 1 is 1. 4 times 4 is 16. Okay. And then 2 over 1 times 1/16. The 2 and the 16 reduce to 1 over 8. So it'll be 1/8 minus 1. And then instead of 1, I'm going to put 8 over 8. So that'll be negative 7/8. So that's what cosine of 2 theta is, okay? All right, so next, do our half angle ones. All we need to know is cosine for that, right? So for sine of theta over 2, so I'm looking at this formula here. Since we are in the fourth quadrant, sine's going to be negative, right? So this will be negative. Actually, you know what? That reminds me, I made a mistake. This is actually what should be negative, right? Because this is in the fourth quadrant, is regular theta. So that means sine should be negative. So this should be negative here, which makes this negative, right? Because it's a positive times a negative times a negative. So this should be negative. This is okay because cosine is still positive, so that's all right. Even if we plugged in negative sine, we would have been squaring, so that would have worked itself out. But we did end up with a negative, right, for cosine of 2 theta. Now for cosine of theta divided by 2, so if we if we get a half angle, that means this will be from 135 to 180. And so that actually is in the second quadrant, right? That's quadrant 2. So that means cosine will be negative like we saw, right? Well, actually, that's cosine of 2 theta. I'm sorry. Cosine will be negative, but sine will be positive. So negative cosine, and we'll have positive sine in the second quadrant. So this actually is going to be positive, not negative. All right. So anyway, let's see. Sorry about that mistake, detour there. So it's going to be 1 minus, instead of putting cosine theta here, I'm going to put 1/4. Same for that, right? So so it's going to be 1 minus 1/4 over 2. And so that'll be negative 3/4 over 2. All right, once again, another silly mistake. Positive 3/4. 1 minus 1/4 is positive 3/4. All right, and so over 2, and so that'll turn into, let's see, 3/4 times 1 over 2, right? Multiplied by the reciprocal of 2. So that turns into 3/8. So this will be square root 3/8, which will be square root of 3 over square root of 8. You could, if you wanted to, multiply by root 8 on top and bottom, but remember that 8 actually breaks down to 2 times 2 times 2, right? So you can bring a 2 out, and then a 2 gets left over. So it's going to be root 3 over 2 root 2. So then we can just multiply by root 2 on top and bottom. So we'll end up with root 6 on top, and on the bottom we'll end up with 2 times 2, which is 4, right? Because this will turn into a 2, and then we already have a 2 out there. So this becomes root 6 over 4. Oops. Root 6 over 4. So that's sine of theta over 2. All right, and that's going to be positive like we said. Now cosine of theta over 2. Remember that cosine is actually going to be negative, because if we divide, if we're in this range and we divide our angle in half, we're going to end up in the second quadrant, which makes cosine negative, right? So cosine is going to be negative 1 plus 1/4 over 2, right? So we put 1/4 in there for cosine, and so that's going to be negative square root of 5/4 over 2. So then we'll do 5/4 times 1/2, and so that becomes 5/8. All right, and then we can split that up. Root 5 over root 8. We know root 8 is 2 root 2. So recycle some of that work if you can. Multiply by root 2 on top and bottom. And so we'll get negative root 10 on top, and on the bottom we'll get 4 again. So this will be negative root 10 over 4. All right, so that's how we do double angle and half angle formulas, right? So that's a good amount of just kind of, just kind of trudging through the calculations there. But we had to do 4 different formulas, right? So anyway, that's how we do it. Let's just kind of go through real quickly, and just, we won't do 2 and 4, but let's just talk about the signs. So here from 90 to 180, that's quadrant 2, right? And so for our initial, sine's going to be positive, but cosine is going to be negative, right? So when we find cosine here, this is going to be negative whatever, right? Like, so 8 over 17 is the 8, 15, 17 triangle. And so this will actually be 15 over 17, but we'll have to make it negative because we're in the second quadrant, right? Now, when we find our half angles, the double angles will work themselves out, so you don't have to worry about that. But the half angles are the ones where we have to know, is it a plus or a minus, okay? So for the half angle, if we divide these values by 2, we'll be in quadrant 1, right? So in quadrant 1, sine and cosine are positive, right? Positive cosine and positive sine. And so so we're going to use positives here when we calculate those, okay? So in number 4 here we're in quadrant 3, right? And so quadrant 3, both are negative. Negative sine and cosine is also negative, okay? So when we find cosine here, it's going to be negative whatever, okay? It would be something over 3, right? Be root 5 over 3, actually. Okay, and the reason that's going to be negative is because we're in the third quadrant. Now, to find our half angles, to do these ones here, we divide by 2, so that means our range is going to be from 90 to 135, which is in the second quadrant. Okay, so it's going to be quadrant 2. So that means in quadrant 2, sine is positive and cosine is negative. Okay, so so we'll use negative for cosine and positive for sine in this in these formulas. Okay, so that's kind of how that's why they give us these, and just to kind of show you how to use those in the different quadrants. So we did these full out, and then these would be very similar, except for the signs would change, because we're in different quadrants. Okay. All right. Let me know if you have any other questions. The next example we're going to do is we're going to actually do like cosine of an angle. So instead of just given the ratio, we're going to be given an angle for sine or cosine, and we'll use one of our formulas to kind of help us out.